Hey, this is Michelle Kittner from the Gulfport School District, and in this video we're going to talk about proportional relationships. This is a two-part video, and at the end of this first video you should be able to identify proportional relationships in a table and on a graph. This video goes with standard 7.RP.2, and in this one we're going to be talking about parts A, B, and D. The vocabulary we're going to be discussing in this video is proportional relationship, and that's the relationship among a group of ratios that are equivalent. So if ratios are equivalent, then they have a proportional relationship. And constant of proportionality, and that's just what a unit rate is called in proportional relationships. So are these proportional? Let's see, let's simplify all of them. If we simplify, we're going to talk about the blue example, and if we simplify the number of people to tables, then we simplify this down to 2 over 1. 8 and 4 can both be divided by 4, so we're going to divide them by 4 and we'll get 2 over 1. 14 and 7 can both be divided by 7 to give us 2 to 1. 20 and 10 can both be divided by 10 to give us 2 to 1. And 22 and 11 can both be divided by 11 to give us 2 to 1. So since all of these simplify down to the same ratio, they're all equivalent, then this is proportional. So yes, this is a proportional, this has a proportional relationship. Let's look at the green box. Distance traveled in miles to time in hours. So let's simplify them. Let's find the unit rate on each of these ratios. So we have 120 to 2, both can be divided by 2 to give us 60 to 1. 240 to 4, both of those can be divided by 4 to give us 60 to 1. 360 to 6, both of those can be divided by 6, we get 60 to 1. 480 to 8, both can be divided by 8, we get 60 to 1. So the green box, the time traveled in miles to time in, or distance traveled in miles to time in hours, is proportional. Those are all equivalent ratios. They can simplify down to the same unit rate. Cost in dollars. Well, let's see if we can simplify it. We may not get to a unit rate, but let's just try and simplify this ratio to its smallest form. 9 to 1, we can't really simplify that. It stays 9 to 1. 13 to 2, those don't have any common factors, so we can't simplify that anymore. It stays 13 to 2. 16 to 3, we can't simplify that anymore. No common factors, so we're left with 16 to 3. 21 to 4, we can't simplify that any farther. No common factors, we're left with 21 to 4. 25 to 5, they have a common factor of 5. They can both be divided by 5, so that simplifies to 5 to 1. These are not equivalent ratios. They don't simplify down to the same thing. So this does not show a proportional relationship. These ratios are not proportional. So now let's look at a graph and see if they're proportional. We're going to start with the blue example that we had, the number of people to the number of tables. Okay, so the questions, when we see a graph, the questions we want to ask, we want to say, is it a straight line? When we plot these points, does it give us a straight line? So we put number of people to number of tables. I plotted the points, it gave us a straight line. So that's the first question. So yes, but there is a second question. We want to know, does the line pass through the origin? Remember, the origin is point 0, 0. It's where the x-axis and the y-axis cross. So if we continue, if we keep this line going, then yes, it goes right through this point right here. So yes, it passes through the origin. So this is proportional. We already knew it was proportional from the previous page, but now we can see on the graph that yes, it's proportional. On the green example, distance traveled in miles to time in hours, does it form a straight line? Yes. Check. And does it pass through the origin? It does. Check. All right. So that again is proportional. Visually, that's how you see it's proportional. Now this one, the gray one, does it form a straight line? Sure, that's a straight line. Now, does it pass through the origin? Well, no, it doesn't. Down here is the origin at 0, 0. It crosses right here at 0, 5. So no, it does not pass through the origin. We saw earlier that this was not a proportional relationship. Now we can see on the graph that it's definitely not a proportional relationship. Okay, the constant of proportionality. It's what the unit rate is called. Remember we talked about that with the vocabulary. It's what the unit rate is called when we talk about proportions. So let's see, when we simplify this down, everything became 2 over 1. So the constant of proportionality here is 2. The unit rate here is 2. The unit rate here, everything simplified down to 60 to 1. So the unit rate is 60, and the constant of proportionality is 60. On this gray one, we said it's not proportional at all because all these unit rates would be different. This unit rate would be 9. This unit rate, 13 divided by 2 is 7.5. 16 divided by 3 is 5 1/3. 21 divided by 4 is 5 1/4. And this unit rate ended up being 5. Those don't have the same unit rate. They're not proportional. They're not equivalent. This can't have a constant of proportionality if it's not proportional. All right, so that's how we find out whether a series of ratios is proportional, whether it has a proportional relationship, and how to find its constant of proportionality.